And this is to our distinguished attendees. So please, if you have any other question or any question during the course of the presentation, please use the Q&A box to ask your question, and then it will be answered live after the presentation. Without much ado, I'll call upon our presenters, Engineer Michael Kwabnam, and then Mr. Albert Tando, to take us through today's session, that overview of gas operations. Thank you.
Okay, thank you very much, James. Thanks for the introduction, and I would like to take this opportunity to welcome everybody to technically, because it's a virtual tour or an internship of a field trip. Welcome to that 𝙑𝙑𝙧𝙩𝙪𝙖𝙡 gas processing plant. It's a pleasure to have you here. It's our pleasure to take you through our plans and for you to appreciate the ins and outs of actually your taxpayers' money that builds this plant. Albert and I, Mr. Mensah Tando and I will take you through the next 2 days, and we'll take it in turns, and we'll be able to answer all your questions as and when. So feel free, jot them down, and you can ask them as discussed already by James in the Q&A as soon as possible. I'll introduce myself. My name is Michael Kwabnam, Engineer Michael Kwabnam. My background is a chemical engineer, so I can associate with all of the petroleum engineers team and everybody else. So same field. It's a pleasure to be here and continuously learning. Okay, Ghana Gas. So I think any company, the most important thing as an introduction is our vision and our mission. Yesterday, I know Riverson went through 1 or 2 of this. Our vision is to be trusted and a reliable gas supplier. And our mission is to contribute to Ghana's economic development by providing an operating infrastructure required for gathering, and I'm being specific, gathering, processing, and delivery of natural gas resources in a safe, cost-effective, responsible, and reliable manner to our customers. Under normal circumstances, when you are entering the plant, you go through the various checks. And after you've gone through the various checks, as part of a tour, you do a safety induction. Tomorrow, I know my colleague, Mr. Jasu Yaya, will come in and do all the safety part of it. But it is paramount, you need to know that Ghana Gas as a company, safety is key for us. So through an induction process, as you enter the plant, we normally take you through an induction to ensure that before you go on a plant tour, you have a very good idea of all the safety implications in around the plant. And of course, it's always a guided tour and instruct you to make sure that you are following all instructions when you enter the plant and when you're on your tour. So since it's a virtual tour, it's very important for you to understand that. And safety, we have a very, very good track record for safety. It will be broken down in details tomorrow, and that will give you a very good bird's eye view of our safety instructions. Okay, Ghana Gas as a company was established in July 2011. By 2012, we have started the main key building of the processing plant and its allied units. It's set in 3 sections. So we have an offshore pipeline, which connects the FPSO to the GPP. We have a gas processing plant that is also for processing of the gas from the offshore plants. And as well as that, the onshore main line from Takoradi through the metering stations and the various pre-CR connections. So when you think about Ghana Gas and our operational infrastructure, you look at an offshore pipeline, you look at a gas processing plant with its allied connections and enhancements, and as well as an onshore pipeline system network to transport the processed gas to its required destination to our various different customers that we manage all across the country. As we all know, we got oil in 2010. The first commercialization was in 2010. And the government deemed it then that gas is extremely important to our power generation side of things. And of course, gas is cheaper in terms of buying light crude oil to run most of our thermal plants. So gas became a paramount to bring the gas that we have available offshore, build a processing plant in order for it to be processed. And main objective at that time was to quickly use it for power generation. Okay, so I want us to take Ghana Gas, we'll take Ghana Gas through a journey of the various different places where we have been, the accomplishments we have gone through, and then I'll break them down as we go through. Albert and I will take this presentation in turns. I'll do some bits of the slides, and he will take over when he gets his opportunity as well to go through. So we started construction of the gas processing plant in Atuabo, where you will be or where you are now, in 2012, May. So construction, network of pipelines was started. I'll talk more about the design of the pipelines a bit later. And then by November 2014, we had our first gas. That's the process plant was built. The network of pipelines offshore and onshore were in place. And the first gas from the FPSO had come into the gas processing plant for its conditioning and separation accordingly. In 2015, one high note is the commercialization of the gas processing plant. So the plant is designed for 150 million standard cubic feet of gas. I'll go into more details later. We have an offshore pipeline of a 12-inch, around 58-kilometer pipeline, and an onshore pipeline, 110-kilometer onshore, to transport the gas from Atuabo gas processing plant through to Aboise, right through to Tema, and it tees off also at Prestia for to go to Prestia also for power generation and various aspects. Okay, one high note, 2017, and this is where I think as an SPE member, as a Ghanaian, and as a student, you really want to take interest in. We, as part of your design processes, you probably will go through a process where you design maybe a pump, maybe a processing plant, maybe various different designs, but you go through what we call redundancy in terms of maintenance, and normally we call it an N+1 philosophy. So if you have a processing plant and you have a unit working, you will normally have maybe another unit on standby. So with that in mind, we built a backup for our de-ethanizer overhead compressor. I'll go into more details what a de-ethanizer overhead compressor is, but all I'm trying to get you to understand is, as an engineer, you need an N+1 philosophy, a unit running and one running on standby. So with this key de-ethanizer compressor, it was paramount that we had an extra one in order for us to shut down the plants, and then do maintenance for a period of time before we start up the plant. But it becomes seamlessly, one is working, one is being maintained, and vice versa when required. We also use that same time to build our 75-kilometer, 20-inch pipeline, which tees off from Esiama to Prestia. I'll give you a vivid understanding of that as I go through my presentation. And the third and the most important out of them all is we fully indigenize the gas facility in operation. When I say fully indigenize, I mean that between 2012 and 2017, we had construction being done by third parties who mostly are not Ghanaians. We commissioned the plant in 2014. We had the plants being operated by third parties who are not Ghanaians. And we as owners looking behind, watching them learning. By 2017, we have taken over the learning in 2015, in 2016, and now we were at the forefront actually operating the plant. And the third party going through a supervisory role to ensure that everything was being done properly. By 2017, the plant was fully operated by Ghanaians. Loads of our staff at KNUST are all universities all around the country, which most of you are part of, and we are very, very, very proud of that investment in our country. So as we speak, the whole plant with its allied equipment and stations are being fully operated and run by Ghanaians like you and I. So tomorrow, if you come to Ghana Gas as a staff, as an intern, as an SPE, a national service, we will teach you the various different ways in order for you to be equipped enough to operate a gas processing plant or units within a gas processing plant according to the sections that you find yourself and you specialize in. In 2018, more projects going on. We're building a loading gantry, which is commercialized at the moment for LPG transportation. We're expanding our pipelines stations to be able to put more gas, and then Gensa pipeline station, which will go as far as Kumasi, which is ongoing at the moment. I'll say more about it through my presentation as well. By 2019, we have fully operating our Esiama-Prestia line. Esiama-Prestia line going towards the eastern and going towards Ashanti region, serving the power generation, serving the mining companies up there, and eventually connecting in Kumasi in future, or very, very soon to Amandi, which has moved from Abuazi Thermal Plant. We're also looking into the future. We're looking into designing of a new plant. I remember yesterday, our commercial colleagues discussed extensively about doing a train 2, that's a gas processing plant 2. And this was envisaged right from 2019 and still being worked on as we go through this process. By 2021, we have established various networks where we are supplying gas to third parties who are either ceramic operators, small companies taking some of our gas, which generates Ghana Gas also some revenue. And by 2023, we are still looking into getting our train 2 established and various future plans ongoing. Okay, so I said something right from the beginning. Ghana Gas is split up into an offshore facility, which is our pipeline, offshore pipelines. We then have a gas processing plant, and then we have the onshore pipelines transferring the gas throughout. We have 3 FPSOs, and if it was a Q&A question, I would have asked, what is the 3rd FPSO? But these 2 FPSOs, that's the Kwame Nkrumah, that is the Atta Mills, which are in the Jubilee and 10 fields, are the FPSOs that bring raw gas. Yesterday, Riverson stated on that, raw gas, Dr. Riverson stated on raw gas that comes into our plant. So when you drill oil, you have various types of wells. We have a gas well, and we have associated wells. Associated wells, we touched on it yesterday, contain both oil and gas. So once the oil is separated from the gas bit, which is virtually between ethane, that's your carbon chain 1, to your carbon chain 6, is separated, and network of pipelines is brought to the gas processing plant for processing as raw gas, and also called wet gas, as we explained to you yesterday. So the FPSOs are connected at the bottom of the seabed about 800 meters deep in the seabed with a 10-inch pipeline called a flexible riser, connecting it at the bottom of the seabed. And we have a pipeline end termination, which valves are controlled from there. As well as that, as Ghana Gas, you notice this 12-inch pipeline. So this flexible riser was actually built right at the beginning by GNPC, and Ghana Gas connected to its 12-inch pipeline running from the plant right to the gas processing plant. So this would have been your gas processing plant, or this is your gas processing plant. And it goes through your shallow waters and your deep waters, and it's a 12-inch pipeline. This pipeline is designed, and tomorrow we'll take you through. So this is a bit of a teaser. Tomorrow we'll take you through how a molecule of gas will run through the gas processing plant, the pressures it will be under, and it will give you a vivid understanding of what is going on when we get a molecule of gas, which is coming from the FPSO, running through our pipelines, coming to the processing plants in this initial reception, and the various things. We'll take you through that as well. So this pipeline is designed for flows, a nominal flow pressures. You are looking about 130, 140 bar gauge, as well as temperatures anywhere ranging between 20 to 28 degrees Celsius. And normally it takes the temperature, or the gas takes the temperature of the seabed as it runs through and comes to the gas processing plant. Okay, so you are at the gas processing plant. You have separated raw gas, you have separated crude oil from you have separated the associated gas from the crude oil. Your associated gas contains ethane, methane, propane, butane, pentane, and hexane. So you have this whole set. You also contain water. It contains various impurities. And what the gas processing plant is actually trying to do is separating these components from each other, removing your water, removing your any impurities. Yesterday we talked about Dr. Rivison talked about the fact that our gas is a sweet gas. So we are not removing much of hydrogen sulfide and carbon dioxide from it because it's a sweet gas, and hence the plant is not designed to do those separations. But in various different countries with sour gas, you would have had such materials that you have to remove. So it's one good thing about the particular type of raw gas or wet gas that we do get from the various FPSOs. So these are your key number, and the arrow there is just, you have your C just all right over here, and it's coming, your gas runs through your 58-kilometer, 12-inch pipeline, and it enters the gas processing plant. Enters through the initial station area, as I'm showing, and then it will go through the gas processing plant for separation. One key thing I would like the team to remember, and when you're doing especially such projects, is looking at your project management and looking at various ways in order to ensure that such a project comes on well. You pick the right people, the right companies with the right expertise in the various different areas. For example, you pick the right companies which can design a gas processing plant, a right company that can do your communication system, your satellite systems, your various software systems that will be used. And that is what, as a company, Ghana Gas did. So as project managing, Ghana Gas picked the right companies. The pipeline was designed or the feed front-end design was done by a company in France called Technique. That's the front-end design. The building of the pipeline through the seabed was done by a company called Michael Perry. The design of the gas processing plants, that's the key gas main plant area where the processing of the various different components are done, was done by a company called Thermal Design Engineering, TDE. Communications bits Yokogawa. So as project management, you keep picking the key companies with the right skills network, put them together in order to make the best out of everything you're doing. So this gives you a pictorial view of the gas processing plant. This area is your main process area where the gas is processed. And this L shape up to here is your utilities area. So the utilities to support the main process that is being done. So it goes through various different processes. So as a processing plant, the main objective is to separate your hydrocarbons, your chain 1 to chain 6 into the various components. Ethane and methane, after it's been processed, is separated into your sales gas or your lean gas. This forms almost about 80 to 85% of the raw gas that comes into the plant. Tomorrow, we will even show you how the raw gas, when it enters the plant, how you will be able to ensure that the entrained molecular particles, impurities, your water, how you will be able to separate them in order to make sure that your pipeline is not going through a fouling process and being blocked. So the key objectives, so if you can see the C1 and C2, your ethane and methane will form your sales gas or your lean gas. Yesterday, our commercial team discussed that extensively and explained to you how nominations of about 100 million standard cubic feet of raw gas comes in, and we are able to process something in and around the same amount for power generation and for various different ways for our customers, for tiling, for different companies to use. Then your propane and your butane, Revison talked about that yesterday. And depending on the percentage, your propane and your butane will form your LPG. And that will also go into details on all the separation processes as well. We also have the bit on condensate. So condensate is your butane plus stabilized. And condensate is normally something that we store in our tanks. And then it is very similar to gasoline, but has not reached the right specification for you to use as gasoline in your cars and various purposes. So normally it serves as a raw material and is transported by trucks and goes to thermal oil refinery to increase its octane value to do the required blend. And then that is also another source of revenue, another source of employment, another source of raw material for another industry. So you will notice that everything on the processing plant, very likely most of it are not gone to waste, are used in various different ways. Okay, so as a plant and you having your main hydrocarbons, you will go through the various separation processes. Your towers, your two-phase separators, your three-phase separators, your gas chilling and deethanizer systems, your fractionation systems, and your glycol regeneration systems are some of the key main processes that happen at the main plant. So unit 10, for example, your inlet separation is where you start that is when the gas enters. So the gas enters about 130 bar gauge, flowing roughly, let's say, between 100 to 120 million standard cubic feet of gas flowing through the plant. And it goes through the various inlet separations and filtering for you to start conditioning your gas. When I say condition, you are separating your gas into the various different components. So you are trying to remove water. At the same time, any impurities will go through your filter system, which you'll be able to remove. You're trying to now separate your ethane and methane, your gas phase of your hydrocarbon, your wet gas, from your liquid phase of your hydrocarbon. And then you would then use this plant from maybe as petrochemical engineers and various engineering fields. This plant is actually a Joule-Thomson plant. So when we say a Joule-Thomson plant, it is using a cryogenic effect. When I say a cryogenic effect, is using pressure and temperature, choking your gas, and in order to be able to reduce the pressure, and then separating your liquid part of your hydrocarbon from your gas part of your hydrocarbon. And then it goes through also the various fractionations. I always use this example. Imagine you having, and this is an example we all use when we are, or maybe a class 6 example when we were in class 6 or science in and around that age. You will always have an experiment where you have salt water or water mixed with salt, and you put it on fire with a beaker. Once you boiled your water, eventually what happens? You will have your water boiling because it would have reached its boiling point. And the boiling point, as we all know, is 100 degrees Celsius. Once you hit your boiling point and you generate your steam, assuming you cock your beaker and you use a test tube to get just the steam flowing through the tube, and you have a wet rag at one point round the tube, eventually what happens? Because the rag is wet next to the tube and the steam running through, eventually the steam will condense into water. Gradually, what happens? Your boiling water then evaporates and you will have no water in your saucepan or your beaker. Eventually, this is a test we always do when we are even boiling boiling egg. Imagine if we have salt. Eventually, what happens is you have salt at the bottom. The reason why you have salt is you have not got to the temperature where salt would boil off and also evaporate. So if you think from a layman's term about how the gas processing plant works, we are using temperature and pressure by using the various distillation columns. By using the various distillation columns, the various units, to separate our hydrocarbons into the various components in order to have your methane and your ethane, which is your lean gas, in order to also have your LPG, which is your propane and butane, in order to have your condensate, which is your isopentane. So these are the processes it goes through. Unit 40, which is a regeneration system, is where we try to absorb water from the hydrocarbon. One key thing you need to remember is water is an impurity or it's a substance that needs to be removed from the hydrocarbon. One key reason why is otherwise, with the temperatures and the pressures we are working through, the water will freeze, block your pipelines, cause fouling, and block your pipelines. And that is dangerous to any processing plant running. Okay. As a plant, I'm going to try and go back and do the pictorial view. So I was telling you initially that this L shape is our utility side. So it means that our utility side contains your instrument air and nitrogen system. Your instrument air and your nitrogen system, from your studies, you will know very well that a nitrogen system is used for blanketing. So a nitrogen system, one of the key reasons for a nitrogen system is to blanket your product, for example, your LPG. You want to make an inert gas on top, which we all know nitrogen is an inert gas. So because it's an inert gas, it will prevent air in coming into contact with your LPG or your hydrocarbon product, to ensure that you can never get a fire triangle in order for you to cause a flame. Your instrument air controls your valves, your actuators within the plant. That is why we are able to sit in a control room and then you press a button and a valve will open or it will close due to your instrument air systems that is used to do that. Your heat medium, I talked about temperature and pressures. You will need the correct temperatures, you need the correct pressures, and we use heat medium system to generate that temperature. In Ghana, if you go to, for example, most processing plants, very big processing plants, and some of you may have done internship at store, you normally have boilers that they use for generating steam and using that to generate the right temperatures and the conditions that will separate their various units. Ghana Gas, what we have is what we call a hot oil system. It's called Petrotherm. And this Petrotherm has a very high affinity for temperature. It can be heated as a hot oil to about 400 degrees Celsius. So in doing that, it will be able to help us to various different towers going into our kettle reboilers to assist with most of the separation processes that we have to go through. We talked about the flare system, or sorry, fuel gas. Some of our gas is conditioned and is used as fuel gas, which serves as power generation for most of our plants or most of our generators, which we run on. And one key thing, as a utility area, we are able to generate our own power. We have 3 gas gen sets with a conditioned fuel gas of some of the C1s and C2s, or the ethane and methane. We are able to use that for power generation and to run our processing plant. We have 3 gas gen sets and 1 diesel gen set, which we use to run the plant. We call it a black start gen set. When the plant is fully down, you don't have any gas running through the plant, you will use your black start gen set to run. We treat our own waste. So we treat our own solid waste, we treat our own liquid waste. We have our own potable water system. We have boreholes at both sides of the plants, which gives us groundwater, 150 meters cube per hour, which we are able to fill our tanks. It is the same water we fill to we have a huge 400 meters cube each, 2 tanks for firefighting. As a plant, by standard, this plant, or by standard in all around the world, you should be able to fight fire with your equipment for at least 6 hours. And this plant is designed to do that. It also has a dedicated fire hydrant sitting outside with Ghana Fire Service, readily and available. You know, Ghana Gas is a security plant, and safety, as I said, was paramount to us. We have plainclothes security, we have the national security available to protect this plant. We also have our own measures and various securities in place to run. We also have the military as well doing assisting with us. We also have a very competent and dedicated QA lab, and Albert will give more details into that today and also do a session on it tomorrow for you to appreciate. Remember this, as a processing plant within the main process area, before your raw gas even enters your processing plant, you need to know not just your temperature, not just your pressure, you need to know the composition of your raw gas. Does it have a lot of water? Does it have a lot of impurities? What is the percentage of the ethane and methane, propane, butane percentages that I have in? And then you are able, as an engineer, as a process engineer, as a chemical engineer, as a petroleum engineer, and various engineering skills, then you are able to tweak your gas processing plant in order to be able to process it. So you need to be able to have this continuously, and we have various different points within the separate various units and sections, taking samples. The lab team are going around every 2 hours. We have online gas chromatography, taking samples and letting us know exactly what we are dealing with. Also, the lab team are taking samples on various different units to assist with processing of your product. You don't want surprises. You don't want to have raw gas coming in and you haven't tweaked your system in order to have the required and approved specification for lean gas, or approved specification for LPG, or approved specification for condensate. So in order to make sure that you have various vantage points and the team are continuously going around hourly basis, 2 hourly basis, taking samples, looking at temperatures and pressures, ensuring everything is in perfect condition and continuous flow, because this plant runs 24/7. It does not stop unless there's an emergency shutdown or there's a plant shutdown. Okay. So in terms of what I've spoken about, these are the key blocks for the units. So the main components, as we see here, are your methane, ethane, which will form your lean gas, your propane and butane, which will form your LPG, your butane downwards will form your condensate, and then we have a bit of isopentane. Isopentane is very, very volatile. We separate it using the pentane stripper. We separate it from the condensate. And we also have in future we have to have a market, we have a company coming in place to take the isopentane for power generation. And these are the blocks of units for the main processing area. So unit 10 will take you to your separation, your inlet filters, your inlet gas filters, removing water, removing any impurities, and then conditioning your fuel gas for power generation within the plant. Unit 20 will go through your Joule-Thomson process, the gas chilling effect, the low temperature using the Joule-Thomson principle, the de-ethanizer to separate removing of ethane, to separate your ethane and methane from your heavier hydrocarbons, the debutanizer section to remove your butane and your propane to form condensate, to form LPG, and then to strip off using your pentane stripper to get your condensate. Once you get, so please note this, lean gas, as Riverson said yesterday, lean gas is continuous. So, and it forms 85% of the raw gas coming in. So once it's processed, it joins our offshore pipeline and is continuously flowing through our onshore pipeline, going on our onshore pipeline to Aboise, supplying VRA, to supplying Amandi, supplying the reverse flow through the WAPCO pipeline to Tema. But condensate LPG is stored in the vessels, these vessels. And we'll talk more about it. You'll see more a pictorial view of it tomorrow. They're stored in these vessels. So LPG is stored in these white vessels. They are 200 meters cube each, spherical tanks. And we have that capacity to store 8,000 meters cube. Condensate is stored in these two vessels as well, looking white here. It's 500 meters cube each, so 1,000 meters cube capacity is stored here. The firefighting tanks I was telling you a few minutes about is where we store water for power generation. As engineers, we like process flow diagrams, but I know it's not everybody who is very conversant with process flow diagrams. So I won't talk too much in details about it, but all to let you know is this too is your separation process or your unit 10. So your separators, your three-phase separators, your green bits are your water, your brown bits are your liquid hydrocarbon, your yellow bits are your gas hydrocarbons. And then you go through the filters, then you come into your chilling process, going through your cryogenic. I said this plant is a JT valve, a Joule-Thomson valve, using the Joule-Thomson principle of choking the gas. Deep pressure, the gas is around 110 bar pressure at that point. You choke the gas, and using just a valve, it's just Joule-Thomson valve, you choke the gas to a pressure around 50 to 51 bar gauge. In doing that, you have that cryogenic effect, a reduce in temperature. And this reduce in temperature can be as low as minus 33 degrees. And in order to, when you do that, you are separating your ethane and methanes from your propane, butane, and heavier hydrocarbons. And these are our distillation column, the de-ethanizer to remove any entrained ethane, which joins the pipeline for onshore. And then your debutanizer, which is your LPG. And the various pentane stripper for condensate towers. We'll talk more into details and a nice video giving you a pictorial view tomorrow. And then you have your storage facilities as well. Okay. As a utilities person, I'm a bit biased also on this side. I've talked about the instrument air. I've talked about the flare system. One person will ask, okay, what is a flare system used for? It's one of the key things, this whole unit is one of the key things you switch on when you're starting a gas processing plant. The same with the FPSO has a flare system. As human beings, we have to have a way to remove our waste. We go to toilets, excuse my French, and we also urinate, and also we sweat. These are some of the key processes we go through to remove some form of entrained waste. And that is some form of the same way entrained hydrocarbons that is used. If you're going through a processing plant, you will always have some form of minimum entrained hydrocarbons within the system. And one key network to use is your flare system. So your flare system is able to you have a very nice way of a fire triangle. So you have a source of heat, you have an ignition source, you have a fuel, and you have your air forming your fire triangle. So, and this helps you to burn any hydrocarbon homogeneously in order to have more or less CO2 and water. If you enter the processing plant as a tall person and you see our flare system having black suits coming out, it is not acceptable. It means that we are having carbon monoxide being burned. But if you have what is normally called a blue flame, something like maybe when you're burning your LPG on your cooker, then you know that at least most of the water, most of the burning is more or less a reaction and the outcome is more CO2 and water. It goes through various knockout drum. When we say knockout drum, you are trying to make sure that any liquid which is entrained in the gas is knocked out. Literally, is separated from the gas so that whatever is flared is more or less pure hydrocarbon, which is a safety mechanism more or less for the processing plant. It's the first thing you switched on when you're running a plant, and also the last thing you put off if you are shutting down a plant fully for a long period of time, or maybe decommissioning a plant. We give you the fuel gas system, conditioning the fuel, some part of the lean gas for use within the plant. So we also use some of the lean gas or the processed gas in our plant. And we have the glycol regeneration to remove any entrained water and bring using a glycol, which is a high affinity. From your design, I'm sure you've done TEG and various different ways to use an adsorption process to remove water. And at the moment, as a plant, we are more or less using glycol system. There are various different systems as well that you can use for this adsorption processes. And then, of course, your heat medium system. All your boilers, all your towers I've shown here, these are reboilers. They need heat, and this heat medium system serves as a closed system, hot oil system, compared to other plants which will use steam. Okay, nice. A picture of the gas processing plant and a picture of the main plant area, to be specific. This area, as you can see from the sea, you see the sea you can, or the ocean you'll see here, is where the pipeline, the offshore pipeline, enters the gas processing plant. So that is the right of way for the offshore pipeline coming into the gas processing plant. This unit or tower is our heat medium system. This one, this big one with a bottle shape, is your de-ethanizer to help to remove any entrained ethane and methane, which is your full lean gas, which is then joining your onshore pipeline for lean gas to various customers. This unit or this tower you can see here is your 𝙑𝙬𝙧𝙪𝙖𝙡. That's your LPG maker. That's your propane and your butane are separated from your heavier hydrocarbons. Albert, when I'm getting closer to my slide, I need to stop. Please let me know. So then you have your 𝙑𝙬𝙧𝙪𝙖𝙡. Then finally, your pentane stripper. Your pentane stripper is your condensate, stabilized condensate unit is gained from. So you stabilize your condensate in your pentane strip. These towers, from my experience and from our knowledge, have trays in them, and they also have caps within them to help with increasing your cross-sectional area. I know I'm talking to engineers, so it makes it easier for me to explain. But tomorrow, we'll also give a vivid picture. We have a video, which is very very clear, enhanced video, which will give you an idea of how a molecule of gas, when it enters the tower, the processes that it goes through. And for LPG and condensate, after you've processed your gas, your lean gas is continuous. It joins your onshore pipeline and moves out. Then your LPG and condensate are stored in these vessels. As I was saying before, we have 4 LPG, 2,000 meters cubic capacity stored. We also have extra capacity with Quantum Terminal, which is a third-party company that sells LPG to the market. Ghana Gas, although we produce LPG, we do not sell LPG directly to the Ghanaian market. It also, as you all know, it goes through some various processes or various companies, various BDCs, and hence by law, we don't sell that. So a company like Quantum Terminal, which is by law designed to do that, does that once we sell it to them. Okay, so I think I'm done with my slides. This is my last slide for you. The final bit, I've talked about Ghana gas being set into 3 sections. I wish it was interactive, but it's offshore, which is our FPS, offshore, which is our pipelines, which are connected to our processing plant. Is also connected to the FPSOs, the 2 FPSOs. That is on the 10 field. That's the Kwame Nkrumah FPSO, and then the Atta Mills FPSO. The 3rd FPSO is actually connected to our onshore pipeline. So that one does not bring raw gas for us to process. It actually brings lean gas, and it connects to our onshore pipeline. And then that Ghana gas serves as a transportation pipeline for it to be able to transport its lean gas. That's ENI, that's the FPSO Kufuor. Lean gas connects to our onshore pipeline for further power generation and various units. So the onshore pipeline compared to the offshore pipeline is a 20-inch pipeline, whilst the offshore pipeline is a 12-inch pipeline. Compared to the offshore pipeline, the onshore pipeline is 110-kilometer lateral to Aboase thermal plant. The offshore pipeline is roughly 60-kilometer pipeline connected to the FPSO. We also have a 20-inch pipeline which moves from a Siama distribution station, which goes then straight to Prestia and onwards. Albert will show you a very good presentation on that today and give a breakdown of that as well. We also have block valve stations. So every section of the processing plants, of the onshore pipeline, has various block valve stations within the long pipe of 110 or 75 kilometer. And that will help us for maintenance purposes. We'll show you a pictorial view on the various different slides that we are going through. And we have various distribution stations and metering station. Remember this, it is very important. And tomorrow we'll talk more about it. Ultrasonic flow meters. It is very important for us to be able to meter every gas that enters the plant, and then also to be able to meter every gas that leaves the plant. And also through the distribution stations, we should be able to do exactly that as well. And we'll talk more in details about it. Albert, I think it's your turn now. James, I think it's Albert's next slide. So Albert, I don't know if you want me to come off so that you can take over and be able to control it.
No, Michael, just since you are going to be on and you know the material ready, once I get to the bottom, I will give you thumbs up to move on to the next slides, rather than fiddling with it so that we don't end up losing it. Is that okay?
That is fine. As long as I don't have any internet breakages on my side, I'm willing to do that. If I do, then please take over.
I shall do that then. Thanks a lot. Please, can we move on to the next slide, please? Thank you very much, Michael. As Michael said earlier, tomorrow we shall delve in a bit more about the nature of the molecules that we get all the way from the FPSO into our plant before it goes and is processed in the plant. Then after it leaves the plant to our various clients. We cannot do that without analyzing what is coming in. And the lab is the team or is the department that deals with it. Every molecule of gas that comes in here is frequently analyzed by the lab team, and the lab team becomes the eyes for the process engineers in the plant, as well as those in the central control room. So periodically, the lab team has to go and take the sample of the raw gas that is coming in, analyze it, and share it with the control room engineers. Depending on the DNA of the gas that comes in, process parameters will change or might be changed or might be kept as it is. And fortunately for us, we don't synthesize anything here. So whatever gas that comes into the plant, that is what we have to do. We have to work with. We don't have any catalyst in-house to be able to use it to join molecules to molecules. If you want, let's say, carbon with number 4, a butane. We cannot join 2 ethanes together to produce a butane. If you want butane, we cannot cut a carbon number 4 into 2 and add hydrogens to it to get ethanes. In our case, that would have been synthesization, and that would have required catalyst to do. In our case, we don't do that. What we get in, we play in the plant. The process engineers play with temperatures and pressures to get our various products. So the lab team will analyze the raw gas that comes in. They will tell the process engineers, they will share the information with the process engineers. The process engineers will make changes through pressure or temperature for us to enable us to get the sales gas that we would want. And out of it also, we will analyze the sales gas to ensure that it is within specification. We will then take samples as well of the LPG that is being produced, as well as the condensate that will be produced as well, to ensure that it fits within the standards which had been put by Ghana Standards Authority as well as the NPA. So the lab team acts as the eye for the processing plant. The key instruments that you see here on the left-hand side where the lady is, it's the, what you call it, automatic distillation unit, which actually delves into distilling the condensate that we will get to be able to give us the different fractions boiling points. On the right-hand side is what we call the gas chromatograph, the GC, which also gives us the DNA, the hydrocarbon makeup, the compositional makeup, comprehensive analysis of the hydrocarbons that are present within the gas that comes. Also, the GC as well can be used to determine the hydrocarbon composition or the hydrocarbon makeup of the condensate. So we are basically able to know all the different isomers that are present within the, be it the raw gas or the sales gas or the condensate or the LPG that is present in. Tomorrow, we shall basically have a look at the different hydrocarbons makeup of the LPG and the sales gas, as well as some of the condensate that we send to our off-takers. As we are all technical people, or most of us are technical people, we are pretty aware that in the hydrocarbon sector or the petroleum sector, basically that is what makes the world. It is from these that the plastics are made from. It is from these that the car seats are also made from. The plastic sector has its life within the petrochemical industry, the petroleum sector. But for us, fortunately, we are only dealing with gas, as Michael made mention earlier. What we get, we want everyone to understand that what we get in our plant is purely gas. And it is gas that we work on, change our parameters for us to be able to produce the products that we get, which will be the sales gas, the LPG, and the condensate. We do not, and I repeat, we do not receive crude oil. Crude oil will be received by refineries for them to do the distillation and fractionation. In our case, our feed is raw gas and not crude oil. So the lab team will handle the gas that comes in and every product that comes off it after processing. Michael, please move on to the next slide, please. So this will be a typical example of our product stream. On the left-hand side is where we have the FPSO, which you know as the floating production. The S is for storage and offloading. Now, on the FPSO, as Dr. Riverson made mention earlier, we know that someone made mention that they wanted to get into drilling. If they don't get in drilling within the mining sector, they would want to get into drilling on the FPSO, which Dr. Riverson disabused their mind that, yes, we don't do drilling on the FPSO. It is true, drilling is not done on the FPSO. However, the F is for floating, which is the vessel. There's production that is going on, the crude oil, and in this case, because it's associated, well, the crude oil and the gas that is coming in is then separated on the FPSO. The gas is not stored on the FPSO. On the FPSO, they would take a small component of the gas to use it to fire the plant to produce their own electricity. It's not going to be ECG sending them electricity. So on the FPSO, they do have the power to produce their own electricity. Just as much as we in the plant, as Michael made mention, we have got our gas generators as well that we process some of the gas to generate electricity. So the FPSO doesn't store the gas. The storage component of the FPSO is the crude oil. And when they store up to a certain limit, another vessel comes in and they offload it. It's like how you put a tube in a container and transfer the products of that container into another one. That is what the offloading. So it's offloading of crude oil. It is not gas 24 hours a day when FPSO is in session, and Ghana Gas as well is in session, and also our off-takers are in session. We are receiving gas 24 hours a day from the FPSO. 24 hours a day we are processing this gas, and 24 hours a day the off-takers are taking this gas. We are not storing any gas. Everything that comes in, every molecule of hydrocarbon gas that comes in, we will process it. We will use a tiny amount of it to generate electricity for our use in the plant. And then everything, all the gas will then go to the off-takers for them to use it to produce energy for the market. Now, if we were to get 100 million scarf of LPG, this is the typical, 100 million scarf of raw gas from the FPSO, be it either from Kwame Nkrumah FPSO or Atamil's FPSO or the combined FPSOs, if we were to get 100 million scarf, 90% of that will end up being the sales gas, which we will also call it the lean gas or the dry gas, because we would have stripped the liquid components from the raw gas. This liquid component is what will become our LPG and then our condensate. So 10% of the raw gas that comes in, normally by rule of thumb, will end up being the liquid components, the hydrocarbon liquids, which will later fractionate it to become our LPG and then that of our condensate as well. So the sales gas will then go, when we initially started operation of the plant, 100% of the sales gas was going to VRA in Abuaze. Along the line came on the Amiris and the Car Powers and the Twin City Energy. Then we started giving a certain portion as well to Twyford and Wankan and Jantao for them to use it to generate electricity to process and produce tiles. So that was the bulk. When we started operations, the bulk was going to VRA. Everything was going to VRA until we got in ENI, as Michael made mention, which brings in sales gas. It does not bring in raw gas. It brings in sales gas, which joins our onshore pipeline about 10, 12 kilometers from our main plant. And that is then sent to the various off-takers. So when they get there, metering is done, and they have their contracts with their various off-takers. They will take the quantum of gas, lean gas or sales gas that they put into our 20-inch pipeline. It will go to their off-takers, and ours will go to our off-takers. Then LPG will then be sent into a third party called Quantum Terminal Limited, which is about 2.5 kilometers from our gas processing facility. They are the ones mandated to sell the gas to the general market. So we will analyze the gas, the LPG that comes in, then we will send that report to Quantum and MPA. It's in specification, then that is when Quantum will then sell it to the market. The condensate, which is similar to petrol, however, the specifications of the condensate does not meet that of petrol. It is inferior to that of petrol. So condensate will then be stored in the tanks, and other third parties will come in They will purchase the condensate, and then the condensate will be taken to thermal oil refinery. It will then be upgraded either into petrol or into premix, depending on whatever contractual obligations that they have with thermal oil refinery. Then that will then be sold into the market. So technically, we are getting raw gas. After we have processed it, we end up getting three main products currently. That is why they have got the solid lines. That's the sales gas, the LPG, and the condensate. The broken lines is the pentanes. Now, pentanes are very, very volatile hydrocarbon components. Currently, it is a fuel as well. Currently, we are not selling it to the market. However, we have the hope that a third party will take the pentanes and then will use it for power generation. So when the third party comes on, we will end up getting four main products from our raw gas that we process. It will end up being the sales gas, the LPG, liquefied petroleum gas, and then it will then move on to the pentanes, and then it will move on to the condensate. As you can see from above, the sales gas mainly is made up of the carbon number 1 and carbon number 2. That is the main component of the sales gas, which is the methane and the ethanes. By virtue of molecular weight, the LPG will mainly be propane and butane. That is the C3s and the C4s. Once we get into the C4s, we start having the different isomers. So we strip off the C3s and the C4s, which becomes our LPG. In certain jurisdictions, they will split it into two, as Dr. Raverson made mention yesterday. Normally in the temperate regions whereby it's no all that, LPGs normally will be called propane gas because the bulk is made up of propane. When it is winter, we need it to light up quicker than that of the butane. And the fact that the C3, the propane, is lower in terms of molecular weight as compared to that of the butane, is more likely to light up quicker than that of the butane. So in the West, they'll call it the propane canister. That is effectively the LPG that they are talking about. But in our case, we, according to the specifications within the country, we have got a certain mix of propanes and the butanes, which constitutes our LPG. And then we move on to the pentanes, which will be the C5s, different isomers there. So the bulk of the condensate will then be the C6+, which will be the hexanes and the heptanes and the octanes and the different isomers that will be present in there. Michael, can we move on to the next slide, please? So, as Michael made mention earlier, this is a pictorial view of our onshore gas pipeline infrastructure. On the left, where there is the square block, is just imagine that this is where our gas plant is at Atuabo. The red line illustrates, it's not red in real life, but to give us appreciation and color, it illustrates the 110-kilometer pipeline, 20-inch pipeline, which is made of carbon steel, which goes under 3 different rivers, goes through the mining sector, 110 all the way from Atuabo to Aboase. On it, we've got 2 diamond shapes on the red line, which is the block valve stations, which enables us to do maintenance activity. So in case there is a leak on the pipeline, whichever sector that there is, Michael, can you come between the sector between Isiama and the block valve 1, please? Any on the line there? Yes. Any of the line there, the blue one is the Isiama to Pristia. It's a 75-kilometer, 20-inch carbon steel pipeline. Now, if there is any leak, all we have to do, depending on the section that it is, the leak is at, we don't have to get rid of all the inventory of gas that will be present in. If it happens where the arrow is where Michael has put it in between Pristia and this diamond, the block valve station 2, all we have to do is to close the block valve station there, the valves there, and also that of the Pristia 1. And we can then deal with the inventory of gas that is within that section. And it will help us save all the other inventory of gas that will be from that downstream of it all the way to Isiama and all the way to Atuabo. So the block valve station is very, very essential for us, especially having the pipeline onshore, on land, as compared to if it is in the sea, then it becomes a different kettle of fish altogether. That will be that of the West Africa gas pipelines. But in our case, our gas pipeline, what Ghana Gas owns is the onshore pipeline, apart from the offshore 58-kilometer pipeline that comes from the FPSOs into our plant. But all our onshore pipelines transport or transmit lean gas to our various stakeholders. Next slide, please. So this is another picture of some of the pictures of our stations. The TDAs means third-party distribution station, the SRMA secondary regulatory metering stations. Those are what it is there. We've got, when the lean gas goes there, they have to meter it, they have to regulate the temperatures of the pressures before they can send it off to our various off-takers. Different off-takers have got different temperature and pressure regimes. So knowing which off-takers and their pressure regimes, it will be regulated that way and it will be sent to them. Over there is a car power ship where we send also gas for electricity generation, and at the bottom is one of our control rooms as well. So can we move on to the next slide, please? Now, as it was reiterated earlier, we get a gas from upstream from the FPSOs, which is the Kwame Nkrumah and the Atta Mills. We can get it from both or we can get it from one, depending on the nomination. The gas will come in upstream. We will process the gas, and then we will send the gas that meets specifications to our off-takers. The plant is made up, Michael said, I'm not going to belabor the point, it's made up of three main components, which is the main gas plant where the gas is processed, and we do have our utilities which is where the power generation comes in. Also, the glycol that is used to feed water molecules from the raw gas comes in as well, and the glycol is later regenerated, as well as the flare system and also our utility air system and nitrogen generation skid, as well as our heaters and all that, all falls under the utility side. And the lab team takes sample regularly, analyzes it, and shares the information with the process control room engineers, and they make the tweaks, the parameter tweaks, when the need arises, so that it ensures that we get products that are within specifications for our off-takers, as well as also for the Ghana market, if it is LPG or if it is condensate. Gas is compressed. We don't do, gases are compressed and liquids are pumped. That is why we have the compression station. We are not a refinery, so we don't pump oil. We don't pump any liquid. The only time that we pump liquid will be the condensate. But condensate is sold from the tanks, so we do not have pumps. Pumps that we will have within the gas facility will be to deal with anything to do with liquid, be it oil, be it condensate, be it LPG. But when it comes to the gaseous matter, it is compression that takes place. So we compress gas, doing similar job as a pump will do to a liquid. So we have our compression station that will compress the gas to the required pressures, which will then be sent to our off-takers. Also, the lifeline, the bloodlines or the veins that we have to transmit or to transport this gas is the pipelines. And the pipelines come in, we have two main components of the pipelines, the offshore one, which is the 58-kilometer pipeline in the sea, and then the 110-kilometer pipeline from Aboase, from Atuabo to Aboase, and then the 75-kilometer pipeline from Isiama, which is about 25 kilometers away from our plant to Pristia. And then we have our stations as well. Some of them are manned and others are not manned. The manned ones normally end up being the distribution stations and the regulatory metering stations. But unmanned ones ends up being the blowout stations. But fortunately for us, we do have a fiber that is stretched along the pipelines. So we are able to determine if there are any changes, if there's a pressure pipeline, the fibers, any issues that is going on are unmanned. So Michael, can you move on to the next slide, please? Now, this is very beautiful and this is very costly as well. The solid lines basically are the pipelines. The blue ones at the bottom left is an example of the FPSO. Ghana Gas gets gas from FPSO Atta Mills and FPSO Kwame Nkrumah. Kwame Nkrumah was the first one from the Jubilee fields before Atta Mills. 3-4 years later, Atta Mills joined and we're getting gas from the 10th field. The gas commingles, it comes into our plant, we process the gas, and the gas is sent all the way in the green ones to Aboase and then the other enclaves, depending on the use or requirement of power. Then we get also gas from the FPSO at the Kumkufor from the Sankofa fields. But in this case, this is lean gas that is coming in. Now, I just want us to look at a certain picture. We've got 3 different types of FPSOs. On one of them, one is processing the gas onshore. The other 2 do not process the gas offshore. Sorry, one of them is processing gas offshore, that is on the sea. The other one does not. So the other 2 that does not process the gas offshore is where we get our gas from. So it means that even the FPSO configuration can be so different. You can build an FPSO that will process the gas offshore, or you can build an FPSO that does not process gas offshore. So engineers, being the technical people, all is economies of scale. It boils down to power, and it boils down also to money, ability to be able to pay for the different FPSOs, and the time requirement, time constraints will determine also what the economics involved will determine also what you want to do. So in our case for Ghana Gas, we are getting gas from the Jubilee Partners, which is headed by Tullow. So when we say Tullow, it means that it's the Jubilee Partners, which include the GMPCs and the Cosmos and other firms as well. That is where we get our gas from, and we process it in the plant and we send it. The lines that are not blocked, those are what we intend to build, because we intend to build a pipeline from the Atuabo to the Ivory Coast, the Jomoro side, which will later be used for fertilizer production, because fertilizer production mainly requires ammonia. Now, if it came down to fertilizer production, someone would like, how are you saying that you are going to have a fertilizer plant, but we are giving them gas, and ammonia we know is made up of nitrogen and hydrogen. So what they will then do is that they will take our gas, the hydrocarbon gas, break off the hydrogens that are on the hydrocarbons, and then they will go by a Haber process, which will be extracting nitrogen from the environment, and with the right catalysis, the catalyst and all that, they will then join this nitrogen and the hydrogen to form the ammonia, which will be the main component of the fertilizer. That is yet to be done, but that is part of the plan. So all the broken lines means that the projects or the expectations of the pipelines that are yet to be built. So as the Kumasi one, we know we have, as the Kumasi one, all the broken black ones and the red ones are pipelines that are in the plant to be built, either by Ghana Gas or other third parties, depending on what the government's policy is at the time. So can we move on to the next slide, please? So now, this is what I just basically explained. Currently, the solid lines are the existing projects from Atuabo to Aboase, that is the onshore pipeline. The WAGP, that is the West Africa Gas Pipeline, is an onshore pipeline, which is not owned by Ghana Gas, but owned by the West Africa Gas Partners. It sends gas from the Eastern Enclave, that is all the way from Nigeria, from Tema. That is before Ghana Gas came on. That was what it was doing. It was sending gas from the Eastern Enclave to Aboase. Aboase, they were using mainly, a lot of the time, they were using crude oil, be it light crude oil or heavy crude oil. But when Ghana Gas came on, we know that gas is cleaner than crude oil, Ghana Gas cut the cost down immensely into, at that time, if they were spending, let's say, $2 million every single day to produce electricity, with the existence of the oncoming of Ghana Gas, it cut down the cost to about half, less than half, to produce the same amount of electricity, megawatts of electricity. So Ghana Gas coming on became key. So later on, the West African gas pipeline was converted to become a reverse gas pipeline. So where there is a glut of gas in the Western Enclave, that is gas from Ghana Gas and gas from ENI, some of the gas would then be sent to the Eastern Enclave, that is Tema, for them to be able to process gas with. The broken lines are what we intend to have in the future. Currently, there's ongoing gas pipelines being built from Pristina onwards, but the idea is all the way to go to Kumasi, and basically maybe along the line all the way to Ghana, so that gas can be sent to different places for power generation. We know that as more power is transmitted from longer distances, there is that loss that takes place. So if there is a gas power plant, let's say in Tamale, and we have gas that we can send to Tamale, it is better to produce electricity around Tamale and send the electricity to that neck of the woods than to get it all the way from Kumasi. So these are future plans. Next slide, please. Now, as my colleague Michael made mention earlier, Ghana, we have got some very, very amazing technical people. In certain jurisdictions, in certain countries, if I were to use Nigeria and Trinidad and Tobago, when they had their first gas infrastructure, they spent more than 20 plus years before it fully became indigenized. But fortunately for us, due to the sharpness of our engineers in Ghana, as well as the power that was embedded in us by our CEO, who is obviously a gas expert, in March 2017, he told the Sinopec team that was running the plant, that was operating the plant and maintaining the plant, that he believed that in less than 2.5 years, his people, Dr. Benasanti said that he believed that his engineers, his technical people, as well as the non-technical people, let's put it that way, because the gas plant is not solely about technical people. We have the HR, we have the procurement, all of them involved. He believes that the plant or our facility can be run by us. So Dr. Asante allowed the Chinese and all the other foreigners to leave the plant and entrusted us, 100% Ghanaians, to run it in less than 2 years, where the Nigerians and the Trinidad and Tobagos took more than 20 plus years for any of their plants to become indigenized. So that is a major plus to the management to be able to say that, you know what, I'm going to trust my people to do this. And if there is any issue, they were prepared to put their neck on the line and take the blame. So I will share something with you. When the Chinese people left, like almost every month, we used to get calls from them. They will either call myself or Michael or Weiss or someone else, anyone that they have relationship with, and go, oh, guys, how is the plant going? They're expecting to have issues with the plant. A month, there's nothing wrong. 2 months, 3 months, 6 months down the line, there's nothing happening. When the Chinese left, our throughput, we actually even raised the volume of gas that we were processing than when they were here. Our volume output went higher than when they were here. A month now, a year down the line, they were not hearing it because they were of the belief that there is going to be something that is going to happen. We are not going to be able to run the plant as quickly as they thought we were, because Dr. Benasanti told them that, yes, they can go and let Ghanaians run. And how many years down the line? We are 7 years down the line. March will be fully 7 full years down the line. We have been running the plant 100% without any Chinese involvement. We have utilized Ghanaians from all the universities in Ghana and other Ghanaians that have gone to universities as well out of Ghana to help us run the plant. So our management and our board are really for Ghanaians running the company. So I just want to share with you guys that are there that your skills are needed to run the plan. So we've been championing local content matters as well as local content policies. We have been involved with the gas challenge, the first of its kind, where this year, well done to Tech, you took it away from Mines, University of Mines. So it makes a change that University of Mines were not just going to monopolize it, but congrats to Tech as well as all the other universities that have been involved with this gas challenge. When it comes down to major maintenance shutdown activities, it is all done by Ghanaians. Unless there is something that cannot be done, that requires maybe warranty purposes depending on the equipment, that calls for an engineer to come out of Ghana. But even when the engineers come out of Ghana to do it, our maintenance team, our engineers are involved with them in the shutdown activities that happens in our plant and also in our various stations. Next, please. Thank you very much, team, for listening to us. I hope we didn't go down too much over. We are now ready for questions and answers. Thank you, Team SPE.
Thank you so much, Michael and Albert, for taking us through today's lecture. Very interesting, of course. I've been sitting here listening to a lot of technical details that you managed to explain so simply for us to understand. At this juncture, I think we would have to allow a kind of open forum for us to take Q&A, contributions, suggestions here and there. So for participants or attendees, if you have a question, just kindly raise up your hand. I will see you on the chat and I will mention your name and you quickly come in and ask your question. We have less than 30 minutes to do this. So let's be concise with our questions as we proceed. If you are not too conversant in speaking, kindly put your questions or comments in the chat box. We'll be able to answer you quickly. So I have a few hands up here. I'll begin with Samuel Gamo. After Samuel, I'll take Patrick, Justice Abuchi, then Luz Crenshaw, in that order. So Samuel, let's have you have your questions. All right. Kindly unmute yourself. Okay, let me allow you to talk. Samuel, you can talk now. Hello, Samuel.
Please, can you hear me?
Yeah, we can hear you now. Kindly ask your question.
Okay. Good afternoon, everyone. Please, I want to ask what you do with the canteen currently, since you are not selling it, so there's nothing at stake with it.
All right. We'll take the questions and then they'll come in and answer quickly. Samuel, I think you can lower your hand now. Patrick.
Okay.
Hello, good afternoon. I hope I can be heard.
Yes, please.
Yeah, manager, thank you very much. This is Patrick Justice. Manager, thank you for the insightful explanation. My question is on the pipelines that we are, whether private or public, building to the north or the Ashanti region and some part of the western region. We have a gas master plan. I want to believe that all pipelines, gas pipeline going to Ashanti region, we're following the gas master plan, or is there something we are doing different relative to that? We actually following the gas master plan that is in place for the transmission of gas resources to the North and Ashanti region? That's the question I want to ask the manager.
All right, thank you so much. Lucretia, please ask your question quickly.
Hello, good afternoon. Thank you so much for this opportunity. Please, I hope everyone can hear me.
Yes, please.
Okay, so at the point where Mr. Albert was explaining, sorry, Mr. Mensah was explaining how LPG is got at 𝙑𝙑𝙪𝙧𝙩𝙪, I couldn't hear. I think there was a system, there was a glitch somewhere. So please, can he just elaborate a little? Because I know there aren't any, what's it called, refineries around the Takrady enclave. So I was just wondering how LPG is being processed at 𝙑𝙑𝙪𝙧𝙪, LPG in particular, please. Thank you.
All right, thank you so much. Albert, I saw your hand now, but let me ask a question in the chat room that says, since GENSA has constructed a gas pipeline in Kumasi, does Ghana Gas plan on constructing one also or using that pipeline? Yes, or using that pipeline. So I will allow our presenters to provide answers to these 4 questions. Then I'll take the next set of questions or read out the next set of questions in the chat room. Thank you so much. Over to you, Albert and Michael.
Okay, thank you very much. Albert, we take 2-2?
Okay, Michael, initially, there was an issue in the plant, so I dropped, but I've come on my phone. So the only bit that I heard, the questions that I heard was, there's a young lady who made mention about LPG production in the plant, and also I heard the latter bit of the GENSA one. So if I can take the latter ones.
Yes, that's fine.
And
that's
okay.
Fine. Please.
So should I take the latter ones first, then it will come down to...
Yes, please. Yes, please. Okay.
Now, I'll start with the LPG production. As during our presentation, we made mention earlier that we do not get, everything that we process, we end up getting sales gas, which is made up mainly of methane and ethane, and we get the LPG as well. So what happens is that we get a raw gas that is made up of different hydrocarbons present in. So we can start with the methane will be present in the raw gas, ethane will be present in, propane will be present, butanes will be present, pentanes, hexanes, octanes, all the way down as the molecular weight gets bigger, it changes the state into liquids and onwards. So what we do in the plant that maybe will throw more light on with tomorrow's presentation is that we will then strip off the raw gas that comes in. We will actually fractionate it, if I may put it in a loose term. We will actually divide it. So if the raw gas, the makeup, we will separate all the metanes and ethanes, which will become our sales gas. Then after we've separated the methane and the ethanes, which becomes our sales gas, we will then move on to the de-ethanizer side, whereby we will get the lower product, the bottom product, which will becomes mainly made up of C3s and C4s. We'll move into the de-butanizer. Now, we call it de-butanizer. In certain industries, they will have a de-propanizer, which means that you are removing only propanes. And then they'll have a de-butanizer, which means that you are removing the butanes. In our case, we do not have a de-propanizer in the plant because of the fast-track nature of the plant that needed to be built. And also, we knew that the Ghana standards of LPG required a mixture of propane and butane. So we had a de-propanizer. So where we have the de-propanizer is that when the bottom products from the de-ethanizer goes into the de-propanizer, the parameters, the temperatures and the pressures will be set in a way that it will be enough to be able to remove the butane components. And if we can remove the butane components from the feed that has come into the de-butanizer, we know by virtue of density, the propane is lighter than the butane. So if the temperatures and the pressures can remove the butane. Automatically, the propanes as well will be removed. And that is how we get our LPG. So that is how we get our LPG. Ours will be very different from if LPG had been produced in a refinery, that they would have used the fractionation columns for LPG production. So we get raw gas, we will process the raw gas, we will get sales gas from it. The same raw gas that we have taken off the sales gas component, the liquids that we get from it, the hydrocarbon liquids that we get will then be fractionated to get LPG. Further on, this same hydrocarbon liquids that will then be left after we have taken off the LPG component, we will further on fractionate it again to get our condensate product. I hope this is clear.
All right. I think you have done justice to most of the questions. I don't know if that is all or you want.
Okay. So James, I think there's 3 other questions, right? That we need to.
Yes.
So Jens, somebody was asking, Jensen has constructed pipelines. Forgive me, I have a cold, so forgive me about my cough sometimes. Yes, Jensen has constructed pipelines, that's correct. And you saw from the flow chart that Albert showed, those flow charts, Albert said it very clearly that these are flow that are not just us. It's not just flow chart for Ghana Gas. It's the whole collaboration of what the country wants to do as a whole. So it means that if a company that, because we work with Jensen, we are working hand in hand with Jensen on a lot of projects. So hand in hand is a company's master plan, and it adds up to what Patrick, my colleague Patrick was asking. Patrick works with us. Yes, so everything is all planned within the Ghana's master plan in terms of pipeline master plan. And as a country and as the various regulators that regulate us, both midstream and downstream, and the government agencies, we are all following the direction that's as a country and as a government we move towards. So yes, it's part of the plan. So that answers that as well. And then somebody was like, Pentane, what we do with it? Yes. So one key thing is because we have not been able to commercialize the pentanes yet, we try and put as much of it possible, because we separate isopentane from pentanes. So we put most of the pentanes into the condensate. So the pentanes are more or less within the condensate. And then the isopentane, which is the volatile bit that cannot be stored completely, we homogeneously flare it, safely flare it, but in very, very small amounts, because most of the pentanes are actually going into the condensate, and then the condensate is transported to toll. I think that's our 4 questions answered. James.
Yes, please. Yes, please. All right. Thank you so much. A series of questions in the chat. Let me try and read them quickly, and then we have answers to them. The first one says, please, what's informed the difference in cross-sectional geometry of the butanizer and one of uniform cross-section, also with the condensate from the main processing plant? What are its properties, physical and chemical? The next one says, what will the carbon separated from the hydrocarbon for the fertilizer for the mantle not getting that question very well. Let me take it again. I think he's trying to say what will be the carbon separated from the hydrocarbon for the fertilizer. Gideon Asante, kindly ask your question again. I'll jump that one. I'm finding it difficult to read it out. Kindly ask that question again. The next question says, what do you think of gas being the ideal transitional fossil fuel? Can Ghana rely on it heavily? Please, what's the percentage of losses you make during processing, and what are the main processes in which losses are made? Please, I mean, what's the carbon be used for? Okay. Gideon is asking, what would the carbon be used for after separation from the hydrocarbon? I think we can take this view and I'll come back and read more of the question. Thank you so much.
Okay, so I'll take some, I'll take some and then I'll put some to you if that's okay. Okay, please, what informed the difference in the cross? Okay, that's a very good question. So, for example, the 𝙑𝙤𝙧𝙩𝙪𝙖, you see that the column is like a bottle shape, and it's more or less the 𝙑𝙤𝙧𝙪𝙖 compared to the deproponizer, you don't have the reflux bit where you can do. I don't know how your knowledge on distillation column is as good as, but you are not able to set fully your reflux ratio and being able to, so it's being in that form, you are able to then ensure that as much as possible, your ethanes and your methanes are washed down, and the pure one is the one you are seeing at the top of your, or your overhead of your tower. So that is what is informing that design to it, compared to the 𝙑𝙤𝙧𝙪𝙖, where you actually have a reflux section where you set your reflux column, and then you use your reflux, a T of your gas or a T of your product coming back, washing down your tray and making the product purer and purer and purer, so that the product you get as LPG is completely clear or completely up to the right specification. What is the difference? What will the carbon separation for the fertilizer? I'll let Albert take that one. And what do you think of the gas being the ideal transaction for, and can Ghana rely on it heavily? I think so. I think for now, as a country, we are torn in between the fact that we are all as a world going towards renewable energy, more greener, but we also have to balance the fully renewable energies like the solar and then the wind, the turbines, and various different renewable energy to some of the fossil fuel. Light crude oil is worse than gas. So, and we have an abundance of gas. So it's a transition for us as a country, and we need to use it transitionally. Our international partners, our Americas and various different countries, they didn't just go off like that. Rome was never built in a day. So I think it's a transitional process that we need to rely on to be able to use to our benefit, whilst we gradually move towards the required Paris Agreement that we have all signed to as a country. What is the percentage losses of you make during the processes, and what are the main processes in which? I think the main things that you would separate is your water, your entering hydrocarbons, but unfortunately we can't give you our detailed percentage losses because that's our proprietary information. What will the carbon be used for? Okay, so that's still Albert, the fertilizer question. And then the next, Albert, do you want to take it? Because I think I'm done with that first section. Okay, otherwise I'll go. Let me see if I can go on, and then I'll pick the fertilizer very soon. Very
Oh, sorry.
educated.
Michael, you wanted me
Yes.
to pick the carbon one?
Yes. So it was
Okay.
like, what would the carbon separated from the hydrocarbon for the fertilizer for the main site?
Okay. I think I got the gist of the question anyway.
Yeah, you got the gist, right?
Yeah, I guess the question that I made mention that yes, pipelines will be built so that fertilizer is produced. And then the fertilizer, as we know, the main component will be ammonia, which will be NH3. So basically, they will break the hydrogen component from it. If they had other means of getting hydrogen in the ammonia industry, they can still go by the Haber-Bosch process, and extract nitrogen from the environment, and then using ion catalyst, for instance, through heterogeneous catalysis, get the ammonia. In our case, the hydrogen supply is going to come from the lean gas. So they are breaking the hydrogen from the, be it methane or ethane or whatever it is, to add it onto the ammonia. So obviously they will be left with the carbon over. Now, for every molecule of nitrogen, ammonia that will be produced, there will be an equivalent molecule of carbon dioxide that will come in. So that is where the carbon, as he posed, it will be turned into carbon dioxide. We know that carbon dioxide, it's not exceptionally good for the environment, but it can be good for the environment depending on where it is being utilized. But there will be sources or uses of carbon dioxide as well that can also come out after the ammonia production. The carbon dioxide can then be used basically as a refrigerant or firefighting extinguishers and other uses of the carbon dioxide. So even though, yes, the main will be the production of ammonia, the carbon, as the question posed, can then be turned into carbon dioxide, which can also then be used for other sources as well, like even carbonated water that is in our fizzy drinks and all that comes from that as well. So that will be the use of the carbon dioxide. And that will be the use of the carbon. And I hope that answers the question.
Okay, excellent. Thank you very much, sir.
All right. Thank you so much. We have a couple of questions to answer. The first one I want to have here is from this Anchor. Sorry. Very educative. I have learned a lot. I have about 2 questions. One, in which situations do you flow through ORF? 2, I was comparing your cold flare at the compression station close to Quantum and the one at ORF. It looks like yours is short. Won't it cause future problems to nearby communities? Thank you very much. The next question, which type of absorption column to use in your facility? Next one says, do you account for the commingling effect of the tail gas from the ending gas to join the tail gas in atuable cell pipeline? Thank you so much for this opportunity. It's been insightful. My question is, looking at the ambition to grow and develop local capacity in the oil and gas sector, what avenues are available for recent graduates to intern and even work with Ghana Gas to develop their potential as well? And do you plan to have sessions like these continuous for many times in the future? The next question says, which will be the last I'll read and I'll allow the presenters to come in, says, I would like to join the team of process engineers. Any direction for me? I have experience in processing plants with chemical engineering background. I will pause here and allow the presenters to provide a few responses to this, then we can move on.
Okay, Mr. Tando, I think I will clear this off. I've seen that there's a lot in the chat. I don't know if you can see it, but there's a lot in chat. So let me clear this once off, then the next group you clear it off as well, if that's okay.
I think that works for us.
Okay. Okay, it says very educative. In what situation do you flow through ORF? Yes, we do flow through ORF. So as Albert was doing his presentation, he said we had a compressor station. It's called a 𝙑𝙑𝙧𝙩𝙪𝙖𝙡 initial compressor station. So on the onshore line, if the gas processing plant is working, it has processed the gas, our onshore compressor compresses the gas for 50 bar after it's gone through the JT valve and it's gone through the cryogenic fit. It pushes it at 50 bar and then it compresses it to 100 bar on the onshore pipeline. That's the 𝙑𝙑𝙧𝙩𝙪𝙖𝙡 initial station. A compression station. So once the compressor for our onshore pipeline, let's say, is not available, is being maintained or anything whatsoever, there's 3 compressors, 100%, 100%, 100%, 3 compressors at ORF, which one of them is dedicated to Ghana Gas. So we can go through their compression system and then they will add their offshore gas to ours and join our pipeline again. So yes, we do use it sometimes if we're going through a maintenance process or a plant shutdown sometimes. On comparing our cold flare to quantum that was ORF, I think it's our design it meets the needs. Remember also we have 1 compressor, as I said. ORF has 3, so design, conditions, and everything, it does meet the needs. It's not an issue. Sensitivity analysis are always done before even a plant, such a unit is designed, and environmental impact assessments approved by EPA and various different international parties. So there's no problem there. In terms of columns for the absorption, we are using packings. So that is the packings within the absorption column that we use. What do you account for commingle effect of the sales gas for the E&I gas to join the sales gas naturally? So you account for the
Michael,
yes.
Can I take that? I think because I've just been reading the chat, so I got the import of it. So can I take that?
Okay, please go ahead.
Basically, I think what the person who posed that question wanted to know was that we have a 110 kilometer pipeline. We were in existence before E&I came about. E&I did their economics and they realized that if they use our gas pipeline to transport the gas to their off-takers, it makes economical sense for them. So they sat down with us and we felt as well that yes, it makes economical sense. What we are going to do is that we will transport their gas for them at a fee. So E&I will send a certain volume of gas in. Obviously, they cannot separate their gas from our gas, but we know the compositional makeup of our gas, and we know the physical properties, the heating value of the volume of gas that we put through. E&I as well knows the volume of gas and the heating properties as well that they put through. Now, in order to know that, there's an equipment called the gas chromatograph that actually analyzes the gas that comes through. So it will then tell you that E&I has put 1 molecule of natural gas in. Out of this molecule of natural gas, 91% was methane, 7% was ethane, 3%, let's say, was propane. So that is 100% there. Now, this, we will then be able to calculate its high heating value. We know our heating value as well. So when it gets to the other end as well, it's the same high heating value that they charge the off-taker with. So so whatever the gas that is going in, if let's say company A is taking from E&I, it's not what E&I puts in that will solely be given to them because it would have commingled with ours. We know how much volume of gas allied with the heating value that we put in, do the multiplication, simple maths, and that is what is given to the off-takers from both sides. So that, I hope that answers your question. Since I'm on, I also saw a question that spoke about impurities that are present in. As Michael made mention earlier, that in our plant, fortunately for us, normally in a gas processing plant, there are 4 main processes that takes place. In our case, we only deal mainly with 2 main processes. The gas that we are getting from offshore is what we term as a sweet gas because the other associated hydrocarbon present with that is the crude oil. It's a sweet crude. That is one of the premium oils that is wanted around the world. The sweetness is linked to the presence or lack of presence of sour components, which we are talking about hydrogen sulfide and sulfur dioxide and mercaptans and all that. They give it a smelly effect. So in our case, we are getting sweet gas. The gas does not have any appreciable amount of this sourness from hydrogen sulfide or mercaptan, which is another family of sulfur present in. So there is no need for us to remove the sulfur component from it. This leads us to even the LPG that we will produce. The LPG that we will produce will then also be sweet one. So normally when we started operations, our LPG did not have a smell. So what we have to now do is that we have to inject mercaptan so that in the event of a leak, we can smell it. So the smelling effect that you normally will smell from your LPG will be as the presence of mercaptan in. So in our case, we are getting a very, very, very good feedstock. That's the raw gas. That does not have sulfur present in. So we don't have to have a sulfur removing unit. And also we don't have so much water present in that we don't really have to set up an equipment massively for water removal before we process it. Even though we will inject glycol into the gas or methanol into the gas to still any other water molecules that might be present in. We don't do massive dewatering like other plants will do, and we don't do desulfurization as well. So I hope that answers the question of the commingle and that of the impurities as well. Thank you. Sorry, Michael, for jumping in, but I was in the flow, so I thought I might as well continue.
Very necessary to be in the flow. Okay. Okay, so there's one from an anonymous attendee. Okay, thanks for the opportunity. Okay, yes, we are always continuously trying to get interns in national service. Please apply the various processes, and once it goes through the processes, we'll be very, very happy to do that. Yes, we are also very happy to be part of various different programs as well like this. This is the first, and we know that it will not be the last. So we'll work with the various executives, and we'll try and continuously be part of it. It's good for all of us. So we don't mind. Would like to join our team. Any direction for me? Yes, please apply for all those various processes, and the HR team and all will be very happy to assist and go through the process. What are the main impurities? I think Albert has answered that already. Has Ghana Gas considered an external off-taker for the process gas? Are there plans in place to increase capacity? Yes, there are plans in place. I discussed that. We are looking at GPP2 to increase capacity. But in terms of off-taker, we haven't even touched the surface of finishing using the gas in Ghana yet. So we even need more gas as a country. So I don't think we would want to be selling gas out yet. Albert, do you want to take some, or should I go ahead?
Okay, I will take some. I saw that there was
Mr.
one by Blay, which made mention of what are the safety measures put in place for the transfer of raw gas from the FPSO to the plant through the seabed. Blay, thanks for that question. That's a tough one, and it's a very good one as well. I think come the end of the session, maybe I think on Friday, there will be a lot of matters on safety, but we do not operate our plant without safety implications. Apart from a nuclear plant, a gas plant is the most dangerous plant that one could be in. So the integrity, the material selection has to be on point, because as we all know, that the fire triangle, in order for anything to burn, it has to be in the gaseous state. Already we are sitting on a gaseous product, so we cannot take chances whatsoever. So the selection of materials on the seabed, as you posed that question, we have a carbon steel, the highest grade carbon steel present that is being used for the 58-kilometer pipeline, which is on a concrete, which is buried. We also have marine security that patrols it. We've got boys on it. We constantly within the community talking to fishermen, making announcements to let them know that this is what is there. So they shouldn't go and hook their nets on it. But imagine we are dealing with what you call it, a nominal pressure of about 140 bar gauge. But our pipeline, our offshore pipeline, can handle 207 bar gauge that can come into the plant. So rest assured, the safety, the integrity of the pipeline is the top notch, because we have to factor in the corrosive environment as well, that this pipeline is gonna lie in for 5, 6, 7 decades, whatever length of time that is. So constantly being monitored. We have the baseline measurements for this pipeline in terms of pitting and corrosion and all that. So we do pay particular attention to it. As my colleague Michael made mention earlier, even in the plant, we've got 3 different types of securities here. So you can imagine our infrastructure, very, very expensive infrastructure. We cannot lose that to chance. So when it comes to safety and security, we are very on top of that. I hope that answers your question as well, Blake. Thank you.
James, you want to list the rest, or should we go ahead and try and answer them in the chat box?
All right, so I have taken over from James. This is Banini talking, Philip Banini.
Okay. Oh, please then go ahead,
So, I think we are done with the Q&A, but there are questions at the webinar chat. The first, I think we've answered. Let me just read through the ones I think we haven't done yet. Then we can move on.
I think we've got to Adams.
Yes. Okay, so for the question coming from Adams, we have answered that already. Makilo, how do you account for the, I think that one too, we've done that. Commingling effects, we have answered that question. Patrick or Patricia is saying, please, how many times do you have shutdowns? What brings about the shutdown? Andrews, I think that question too, we have answered that already from Andrews. Hi, good afternoon to everyone. I read an article on the Ghana Gas Portal recently. In the article, they were having a challenge during the shutdown of the gas plant. They've had to flare out the gas from the wells to prevent blowout. My question is that, don't they have any ultramodern facility to store these flared gases for future use rather than flaring them out? If there is no storage facility of gas, are there any plans in the short, medium, or long term of building such facility in the near future? The next question, why is it that students from universities seeking for attachment, national service, and sometimes employment, you people drag feet? I think you have answered this question too already. It just came in a different form. Please, good day. A very good presentation made. Please, can I get the email address I can send my attachment letter to? Okay, so these are the few questions in the chat. Please kindly respond to them. After responding to these questions, we'll give another chance for attendees to ask questions for like 5 minutes, and we are all out of here. Thank you so much.
So because we are on a SPE platform, I'll say in terms of applications, please direct everything towards the HR department of Ghana Gas. If you go on their website, there are very details on our office locations, whether by email or what's it called, by dropping it in physically, whichever way it will be fine, and then that process will start, and then we'll be able to help with that. I think the second question was on what exactly. I can't see what you read in the chat myself, so I'm a bit.
Michael, I can see that. Can you hear me?
Okay.
Go ahead.
Okay, I can see the chart. Okay, so I will pose a question from, is it McKinley, which was asking about the challenge of the flare. Okay, now pardon? About the challenge of the flare. Okay, let me get this clear.
Albert, that was not that. There was other questions that he's been saying, but I can't actually see on the chat. So that's
okay. So what I've seen on the chat was what I was going to answer to. There was a question about EPA regulations and also the gas being flared from the walls to prevent blowouts. So I wanted to answer that, or have you answered it already?
No, please go ahead. Please go ahead.
Okay. Now let's differentiate between the two organizations. There is the Jubilee Partners, which is led by Tullow, which supplies Ghana Gas raw gas. Ghana Gas does not drill for gas or crude. That is the work of the Jubilee Partners. They have done the drilling. They have got the FPSO. They receive the gas and the crude oil together. They separate the gas and the crude oil. They store the crude oil and they send Ghana Gas the raw gas. There are instances whereby some of the raw gas, Ghana Gas can only operate if our downstream partners can take the quantum of gas that comes into the plant. So if, let's say, for instance, VRA has got issues with their plant and they cannot produce electricity, that means that they cannot receive gas from Ghana Gas. And that also means that Tullow cannot send Ghana Gas raw gas. So if there is an issue with VRA, no gas is sent to them. If there is an issue with Ghana Gas, no gas is sent to us. Neither can we send gas to VRA. If there's an issue with Tullow, Tullow cannot send us gas because that is where we are at. So if what you read was that there's an issue that they have to flare, then maybe what sometimes it will mean is that they have to re-inject gas into the walls, either for enhanced oil recovery, but there's only a certain quantity as well that they can inject into the walls. So I am not supremely privy to the operations offshore for me to hold court for them to say that this happened. So that was why they had to flare the gas. Also to tie in with, there's always economics to it as well. We don't even get enough gas to power the nation. So what will be the point of investing heavy amounts of money into storing gas? Because every molecule of gas that is sent to us, it is utilized daily. So that it's not anything yet for maybe investment in, unlike the Canadas and the Americas, whereby they have got empty walls that they inject the gas in, and later on when there's a need for, they go and open it and then use it. In our case, what comes in is what we use. So the prayer is that maybe we should get more money in the country so that maybe more gas plants can be built in the country, as well as more refineries as well can be delved into. Now, the question of the EPA. We exist because of EPA and Petroleum Commission and Energy Commission. They are our regulators. We do not do anything without aligning to their policies. So all that we do, our existence was by EPA and all the regulators assenting to our existence, basically. So we have got the Health and Safety Department that every month sends reports to EPA. So we are EPA compliant in our activities. Thank you.
Excellent, Albert. There was a question on shutdown and how many times we do shutdown in a year. So per rule of thumb, you normally will run a plant for 330 days within a year and try and use a 1 month to shut down. But it all depends on demand. It all depends on how we normally will line up. Remember, as Albert said, if one unit goes off, that's if Talo goes off, it means there's no gas coming to Ghana Gas. And if there's no gas coming to Ghana Gas, it means that we cannot process the gas and give it to VRA, let's say, especially for power generation. If VRA doesn't produce power generation, it means they cannot transmit it to GRICO. For GRICO to transmit from GRICO powers to ECG and for it to come to your home. So the whole system, a cascading effect stops. But shutdown is normally maybe once a year, and then you spend some time. But you try and have, as I explained before, an N+1, N+2, N+3 philosophy for your units, so that when you shut down, you only shut down to do maintenance only on equipment that continuously run, that you cannot shut it down, like your vessels. So we try and do a lot of shutdown maintenance or planned maintenance work in and around continuously every day. I think that answers that question. The rest has been answered here one way or the other. Unless there's more, please, we are available to answer more questions.
All right. Thank you so much. Someone is asking, can I have access to the full recording of the meeting? Yes, we will be posting the recording on our YouTube channel. We did for yesterday, we'll be doing for today too. So just go to YouTube and type Society of Petroleum Engineers Ghana. You have the recordings of all the series we'll be having on YouTube. I think we are done with the questions. There are no hands up from the attendees. Yeah, there are no hands up from the attendees. So at this point, I think we would have to come to a close for today's lecture. I would like to appreciate Michael and Albert for spending their time with us, giving us this technical lecture for all of us to be aware of what is happening at our gas processing plant. We will have them tomorrow, same time, for another lecture before on Friday, we'll be having 2 more presenters who will do justice to health and safety for us. We are expecting to have the CEO of Ghana Gas, Dr. Ben Asante, on Friday. Okay, I can see a hand up. I want to give a chance to that hand before I conclude. Nana Afrifa,
yeah.
Let's hear you out.
Yeah, please, it's about yesterday. Yesterday I joined and I wanted to ask a question, but my call dropped and I couldn't join again. So please, can I ask it today?
Is it concerning yesterday's lecture?
Yes.
Or anyway, throw the question because we don't have those presenters online today, but you throw the question and let's see.
Okay, so he mentioned that
Who
I
mentioned?
think the first presenter, I've forgotten his name.
Okay.
Okay, so he said, I think VRA's consumption, gas consumption is more than that of the IPPs. But I thought we have a lot of IPPs in Ghana. I mean, IPPs generators are more than that of VRA. So I was wondering how their consumption was more than that of IPPs. Yeah.
Okay. Thank you so much, Nana, for the question. I don't think Albert and Mike can provide answers to this. I will throw this.
I think Mosiko, I didn't hear. I listened yesterday and
Okay.
I didn't hear that, but even in Aboaze consumption of VRA, there's so many IPPs around. I mean, Tema, I know SemPower who do about 330. There's Sona Sogli. Look, I would say more IPPs are there more than the VRA, but maybe adding all VRA's other power consumption. But I have to be honest, I didn't hear that, so I don't know if it's a true reflection of a question or a statement that my colleague made. I don't know. Yeah. Thank you.
All right. Thank you so much. All right. Thank you all for today showing up in your numbers. We'll continue tomorrow, like I was saying, same time with same presenters, Albert and Mike, for tomorrow. Then on Friday, we'll have the CEO of Ghana Gas passing through briefly to give us a word. Then we'll have lectures on health and safety measures, and then gas tariffs and pricing on Friday. We'd like to appreciate Mike and Albert for taking time to be with us and for tomorrow. We appreciate your time, and we appreciate each and everyone on this call for availing yourself to listen to this lecture. Let's be on time tomorrow and on a Friday. Thank you all so much, and God richly bless you.